In this video, we're going to see the solution and scoring guidelines for 2019 AB Free Response question number 5. In this question, we are given this region R right here, as well as two functions, and we need to find the area of region R. So first of all, I got to figure out which function is which. So looking at this, I first realize h of x is a quadratic, x is being squared right here. And it's in vertex form. Even if I didn't know that it was in vertex form, I could still see it's got a negative right here, so it's a downward opening parabola. Well, a downward opening parabola, this looks like a downward opening parabola right here, and indeed it is, with the vertex 1, 6, 1, 6 right there is the vertex of this downward opening parabola. So I've got h of x right here. And I'm guessing this is going to be g of x. Then, well, look, something with a cosine. Oh, yeah, that could be a cosine. It comes back up and it goes down, comes back up, goes down. Yeah, we're just seeing a little bit of it. So great, we've got g of x right there. All right, finding the area of region R then, well, I'm going to need to be integrating. I'm going to have to start on my left endpoint and go over to the right endpoint, and I'm going to do top minus bottom. So let's do that then. All right, I'm going to be integrating from my starting point of 0 to my ending point of 2. I'm going to have the top, which is h of x, which if I look right here is 6 minus 2x minus 1 squared. And then I'm going to need to subtract. It's always top minus bottom, so minus the bottom. I'm going to be careful because I need that negative to distribute onto the entirety of the bottom. And the bottom is indeed negative 2 plus 3 cosine pi over 2x. Okay, great. Don't forget about my dx on the end of that, and I'm well on my way towards this problem. So I don't have a calculator. I've got to solve this by hand. Let's go ahead and see what we can do then. So I have a 6 minus a negative 2. Ooh, I could combine those two terms together. Why don't I do that and make my life a little bit easier? Don't have to do that, but I think it's going to make my life easier if I do that. So I'm integrating from 0 to 2. 6 minus, that would be 8 right there. I still have my minus 2 parentheses x minus 1 squared, and minus will distribute onto the 3 cosine pi over 2 x and dx. Okay, find our antiderivatives then. So our antiderivative then, we want to start with our 8. That's going to become 8x. Next, right here, ooh, I could, if I wanted to, multiply this out. I could definitely do that. I'm going to be a little bit cleverer, and I'm just going to think, well, where did that come from? It probably came from a minus 2, and then, it would have been an x minus 1 to the third power, but that 3 would have to come down. I need a 1/3 to cancel with it, so 2 times 1/3. X minus 1 to the third power right there is going to be my antiderivative. Again, I could have done that by doing a box and multiplying it out and all that, but this is going to work as well. Over on this one, I'm going to have the minus 3. The cosine is going to go to being a sine, but the chain rule tells me I'm going to end up with a derivative of the inside would give me a 2 over pi. I'm going to need to cancel with the sine of pi over 2x. Don't forget about my vertical bar from 0 to 2 right here. So just checking that, the derivative here, remember the derivative of the inside would be the pi over 2. So indeed that will cancel with the 2 over pi to give me back what I'm looking for up here. Great. I've got my antiderivative. One more line now to go in order to get full credit on this. I'm going to then plug in my 2 and plug in my 0. So what are we going to get? All right. So that'll be 8 times 2 minus 2/3 of 2 minus 1 cubed minus 3 times 2 over pi sine pi over 2 times 2. And then we're going to need to subtract off, okay, the whole thing. I'm going to plug in my 0. So 8 times 0 minus 2/3 of 0 minus 1 to the third power minus 3 times 2 over pi sine of pi over 2 times 0. Great. Okay, and since I'm on the free response, I'm stopping right there. I'm not going to write anything more to confuse myself. I'm going to absolutely stop right there. I remember that I always get full credit on the free response if my answer is equivalent to the correct answer. I never have to simplify. So let's see how many points I got on this problem. The first point comes from the integrand right here. So if you have the integrand correct, you get that point. Even if you didn't know the 0 and 2 or you left it without limits on that, if you had the integrand correct, you get the first point. Congratulations. The next 2 points come from here, finding our antiderivative. If you got the antiderivative of those 2 terms correct, that's 1 point, and then the antiderivative of the trigonometric bit gives you the second point for the antiderivatives, and then the last point comes from your answer, a total of 4 points on part A. All right, let's talk part B. Part B is where it starts to get pretty tricky. So region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-section has area given by A of x, and we need to find the volume of the solid. All right, this is weird because they didn't tell me about this cross-section. They didn't say it's a square. They didn't tell me it's a rectangle. They just told me it's area, which is strange. Usually I would come up here and I would say, okay, well, I do know that it's perpendicular to the x-axis. So perpendicular to the x-axis means I'm going in this direction like such. But I don't know. Normally I would say, all right, here's my L. Now I'm going to draw a square, or I'm going to draw a rectangle, or I'm going to draw a circle or something down here. Instead, I know that I've got my L going across here, but I don't know what this shape is. It's some shape, but I know it's got area, A of x equals 1 over x plus 3. Okay. Well, that's all I really need to know, though, because then if I'm going to be finding the volume of this solid, well, what I usually would do is I would find the area of a slice, and then I would integrate it across the whole width of the solid. So let's go ahead and do exactly that. Well, I know what the area of this is. I don't have to multiply or do any math down here. I'm already told what the area is. So integrating then, the volume is going to be the integral from 0 to 2 of the area function of 1 over x plus 3 dx. Okay. Well, great, we can do that. That's going to be an ln of absolute value x plus 3. We're going to evaluate that from 0 to 2, so that gives me ln of 5 minus ln of 4 right there. And points are awarded here. There's going to be 2 of them in all. One of them is going to be for, did you get your setup correct this term? And then your second point is going to come from the answer. So 2 points total on part B. All right, let's talk about part C. Part C is definitely tricky. We have to find the volume of the solid generated when we rotate around y equals 6. Now, fortunately, we only have to write it. We don't have to actually integrate. So let's see what we can do. All right, y equals 6 is up here. And that's the line that we are going to be rotating around. So it's a little bit tricky to kind of visualize this, but if you look kind of carefully in your mind's eye, you can see that there's going to be like some air that's in here. When we rotate this around this line, we rotate around, there's going to be a little region in the middle here that's going to be hollow, that's going to have air. So this is going to be a washer method. Remember how the washer method works. We've got kind of a bigger outer radius, and then we're going to have a smaller inner radius. It's going to look something like this, where we have like a little r. Our little r is on the inside, and then we have a big R that goes all the way to the outside. Our big R is like this. And the region, remember, is something that looks more like this, right? Okay, and it's got air on the inside. So again, we've got the air on the inside of our region right here. And we got to figure out now what this is going to look like. Well, one more thing we want to recall is for the washer method, we have the volume is equal to pi times big R squared minus little r squared, where big R is our big R right here, little r is our little r right here. In our case, our little r is going to go from the axis of rotation to where the edge of the air stops. So the axis of rotation to where the edge of the air stops. Okay, so that's our little r. And then our big R is going to go, again, from the axis of rotation, but it goes all the way out to the edge of the solid. So from the axis of rotation, okay, so here's the axis of rotation to the edge of the solid, right there. That's our big R right there. Okay? Cool. Notice that little r actually gets all the way down to being 0 for a brief, just like single point right there, and then it goes back to being positive again. All right. We're going to, again, to find r, little r and big R, we're going to have to do top minus bottom. So let's see what that's going to end up looking like. All right. So come on down to the bottom. We're going to use our formula from up here. So our volume is going to be equal to pi times the integral. Now we're integrating from x equals 0 to x equals 2. We want to go across the whole solid. And we're going to do big R squared minus little r squared dx. Now I got to actually tell the readers what big R is and what little r is if I want to earn any points here. So I'm going to say that's equal to pi times the integral from 0 to 2 of big R is top minus bottom. On top is y equals 6. On bottom is g of x. So big R is going to be top 6 minus g of x. And don't forget, it is squared. So we got to square it, just like that. Okay. Next, we got to do little r. All right, minus little r is going to be top minus bottom. Let's look at it again. Top, we have y equals 6. Bottom, we have h of x. So it's going to be 6 minus h of x. 6 minus h of x. Just like that. Don't forget to square it. Put your dx on there, and you have finished the problem. Congratulations. Let's see how the final 3 points are going to be awarded. So the first point is going to come from, did you have your limits and the constant, the pi, correct? Congratulations, you get the first point. And then the next 2 are going to come from the inside here. So 2 points for that. One is for, did you get the form right? You know, something squared minus something squared with doing like a top minus bottom, top minus bottom. The other one is like, did you really get everything right? Did you get the integrand fully correct? Okay, thank you so much for watching and have a great rest of your day.